All right. So here in the example or the template case given, we have skip and skip off. This is actually not important here, but you can use skip and close with skip off if you want to literally skip a section, a data that you already write in the dataset. Okay, so you can open with skip and then you type in whatever, anything, keyword, information, data in this section. But for that particular run, you want to skip that. It's not important for that specific run. Then you open skip and close with skip off. Okay, but if not, then you don't need to use skip and skip off. Okay, and then this is just for detailed calculation, but since we don't use or since we use no, it's actually not applicable, the flash calculation, run control, BT minimum, this one. And again, skip on and end skip, it's almost similar to skip and skip off. We will not use these two keywords now in this run. Start of the computation, we will have oil, water, dissolved gas. We will use metric unit. Okay, this is the grids, x to the x direction, 10, right? And 10 to y direction, 10 to z direction. Tap dims, well dims, equal dims, I already explained it in previous videos. Unifit, unifound, unifin, right? LGR, here we have LGR, okay? And I already have a specific video about LGR in my previous videos. You can check at the tNavigator playlist. Now it's new for us, comp W. It enables the it enables the multiple water component. So we will have 4 water components. Water component is not only H2O, but there are also other components that will be considered as a water component. Okay, they are hydrophilics in nature, something like that. Comps, we will have 9 components because it's a compositional simulation. Now new keyword again, reaction. This keyword enables the option for chemical reactions and sets up their parameters. And I use 3 here, so I'm telling tNavigator I will have 3 sets of reaction. Equidims, this is for the aquifer. We have aquifer, right? And now we go to grid section. I will take from this file, permeability from this file, Y from this file, Z from this file, porosity from this file, and yeah, carvin and anvin. This is for the LGR. Okay, this is for LGR, and I have explained that the carvin and then the anvin, the keywords for LGR in my previous videos. Okay, and then okay, so you can calculate here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why you have, yeah, 10 here. So 5, 6, 5, 6, it means that it will be located at 1, 2, 3, 4, 5, and 6, right? The LGR will be located at 5, x equals to 5 and 6, and maybe 2D, y in 1, 2, 3, 4, 5, and 6. Okay, and from Z direction, maybe we can go to layer. It should be JK 2, 3, 4, 5, 6, 7, 8, 9, 10. No, but yeah, I mean this one. Or this one. You can see the LGR. 1, 2, 3, 4. Yeah, I mean for the Z direction, we will have the LGR from 1 down to 10. Okay, hence the data set, it's like that, right? 5, 6, 5, 6, 1, 10, and then you will have 10. 10 to the X direction, Y direction, and Z direction, and then close with nfin. Okay, so that's it for the LGR, and then we will take the properties from property section, this file, and then solution,